Okay, so today we're going to learn how to factor trinomials. And I teach this a little bit different than most other teachers that I know of anyway. And in the book still uses like a guess and check method that I always found frustrating. And then I finally discovered a method that just works all the time without having to do quite as much guessing and checking. All you have to do is figure out play with factors just a little bit. Okay, so but in order to learn about factoring, I want to kind of remember how when we factor out a greatest common factor, it was like the reverse of the distributive property. So factoring a trinomial is kind of going to be the reverse of multiplying two binomials. And you might have learned it as FOIL or whatever, but basically you multiply like the x here would have to get multiplied by the 2x and the -4, right? So x times 2x would give us 2x squared. X times -4 would give us -4x. Then the 3 would have to get multiplied by both things over there also. So 3 times 2x is positive 6x. 3 times -4 is -12. And then you get like terms in the middle usually. So you can simplify a little bit. So this would be 6x minus 4x is 2x. So when we multiply it out, and so I just want to kind of like go over the process so that you can hopefully see that a couple of things happen when you're factoring. So in general, like if you just called it a plus b times c plus d, so how that's going to work out is you're going to get ac plus ad plus bc plus bd. And if you notice, the one thing I want to point out is that this first term is always the first two things multiplied. If you multiply the first two parts of each term, that gives you the first term in the trinomial. When you multiply the last two terms, so first times first gives you the first term, and the last times the last gives you the last term. And then, so that's something that we can always remember when we're factoring. The first term times the first term has to be the first term of the trinomial, and the last times the last gives you the last term of the trinomial. When you do the middle, when you multiply the middles and the outsides, those add up to become your middle term. Okay, so that's just kind of like the pattern I want you to remember. Because as we're working through, now we're going to work through the process of going backwards. And so the easy part of it is figuring out what the first and last have to be, because we're going to end up, our answer is going to be like this. It's going to be two binomials multiplied by each other. There's going to be x in the first term of each one. We don't know what the number in front of x is going to be, and we don't know if it's going to be plus a number or minus a number, but these are the two binomials we have to fill out. The method that we're going to use, and it's not going to make sense at first, it's just going to be the method that you kind of have to remember, and then after you do it a few times, you'll start to make more sense. So what we do is you take the first number, the a, and the c number, and we're going to multiply those together. And what we're going to do, so a times c, and then we're going to put b down here. So for this example on the right side, I'm going to do 7 times -1. That gives me -7. And then my 6 goes down in the bottom. And this cross is just a way to organize the big X or whatever, just a way to organize your numbers. So what we have to do right now is on the left and right, we need to find numbers that multiply to equal A times C, and that add up to equal B. So basically, you're going to take the top number and think about what are all the possible ways you could multiply two numbers to get that. So to get -7, you could basically, your only choices are like 1 times 7, 7 times 1, and now you have to think about this. But it has to multiply to be -7, right? So one of them has to be negative. So it's either -1 times 7 or it's 1 times -7. And you just have to figure out, well, which one adds up to +6? The one that adds up to +6 is the one that has the +7. So all we do is we write a -1 here and a +7 there. And then whatever we started with right here, we write that in front of each one of them. So we got 7x minus 1 and 7x plus 7. Now, if you were to try and say, all right, so then when the factored terms are then this, 7x minus 1 times 7x plus 7. But if you started to multiply these out, 7x times 7x is 49x squared. There's extra factor of 7. So by putting the 7x in both places, we put an extra 7 in. So basically, we just have to divide out a 7 in order to get our answer. And it'll always work out that the whatever extra you put in will always divide out. So it looks like it divides out of the term on the right. If we divide this term by 7, we get x plus 1. So then, right, that gives us x plus 1, and then this one is 7x minus 1. And so you could check to make sure that when you multiply them out, you get the 7x squared plus 6x minus 1. When you do the first term times the first term, 7x times x is 7x squared. So that works out. I'm going to do the last term times the last term. -1 times +1, that's -1. So that works out. Then when you do the middle terms, -1 times x gives you -x. And then the outsides, 7x times 1 gives you positive 7x. And those will add up to your middle term of 6x. Okay, so that's the process. The process is you start off by multiplying A and C. You put that number on the top, then you write B on the bottom. Then you have to figure out two numbers that multiply to equal AC, but add up to B. And then you just put those numbers with whatever your A coefficient was and an X. So, and then then one of the A's will divide out. So let's look at some more examples where we just work through this process. So 3x squared minus 10x plus 7. I'm going to start off by doing A times C. So 3 times 7 is 21. And then my B value goes on the bottom, so that's -10. And I'm looking for numbers that multiply to 21, but add up to -10. And since my trinomial starts off 3x squared, I'm going to start off my two binomials with 3x. And then I just have to remember that on one of those, the 3 is going to divide out. Okay, so now I have to think, what are the numbers that multiply to 21? 1 times 21 or 3 times 7, and that's really your only options. Okay, so now we have to figure out how to make two numbers that multiply to positive 21 but add up to -10. So if we're going to add some numbers and get a negative answer, then at least one of the numbers has to be negative. But if we're going to multiply two numbers and get a positive, that means both of them have to be negative. So what we're going to do is we're just going to make all of our numbers negative over here and then check and see which ones work. So -1 times -21 is positive 21, but when you add these, you're going to get -22. So it's not this pair. But the -3 times -7, that's positive 21. And when you add -3 and -7, you get -10. So that means that we're going to put the -3 and the -7 in there. And just like we said it would, the 3 is going to divide out of one of the pairs. So the 3 is going to divide out there, and we get x minus 1 for the first term, and then 3x minus 7 for the second term. All right, let's take a look at this one. Start off by doing a times c on top. So 2 times -81. That is going to be negative. Instead of writing -162, I'm just going to write the factors. I'm going to write -81 times 2. Because when the numbers get big, sometimes it's easier just to think of them as factors, and then put together different factors to see what you come up with when you're adding. So then our b is -9 still. Okay, so we're looking for numbers that will add up to -9. So I know that like -81 is like -9 times 9, right? So -81 times 2, I could think of that as -9 times 9 times 2. And that can help me, because now if I look at putting the -9 times the 2, that would be -18. So by writing the factors, I was able to identify two numbers that will multiply to whatever this would be, -162. But I found them by looking at the factors, right? 9 times 2 is 18. -18 plus 9 would get you -9. So I'm going to use a -18 and a +9, and I need to start each one of those with a 2x. And I need to divide out the 2 from one of those, and it's going to come out of this one. So we get x minus 18 divided by 2 is 9 times 2x plus 9. And then this one, so again, 5 times 24 is going to be something bigger than 100. So instead, I'm just going to write 5 times 24. Actually, so 5 times 24. And then I need numbers that will add up to -43. So I'm going to probably need to break up this 24 a little bit. So I'm going to think, let's think 5 times 24. One way to do 24 is 2 times 12. Now this number over here, this is positive, right? So the number I'm multiplying has to be positive. The number I get when I multiply is positive. So that means that the numbers that I'm going to multiply have to be the same sign, which means they're both going to be negative. So it's going to be 5x minus something and 5x minus something. Because in order to get a negative down here when we add, these have to be negative. They're both negative because when you multiply them, you get a positive. Okay, so now we're just looking for how can we rearrange these numbers so that they will all add up to 43. This won't do it. So instead of 2 times 12, maybe I'll think about it as 4 times 6 to get 24. So we could do 20 and 6, but that only adds up to 26. What if we did 24 as 3 times 8? Let's see, 5 times 8 is 40 plus 3. So 5 times 8 is 40. So 40 times 3 Yeah, because 5 times 24, that's 120. And 40 times 3 is 120. So 5x, and if we do them both negative, then negative 40 times negative 3 is positive 120, but you add them together and get negative 43. So those are our numbers. So 5x minus 40 and 5x minus 3. And then the 5 is going to divide out from one of them. And it's this one, because 5 goes into 5 and 40. So we end up with x minus 8 times 5x minus 3.